Team 3 Project Insights application demo. Today I'm going to start us off by quickly showing you how to set up the application. If you head over to Capstone Project Team 3 and clone the repository first thing. Once the cloning is completed, you can enter into the cloned project and code.open it with VS Code. Here, first thing you must do is create a .env file. In that .env file, you would get your Gemini API key. So if we Command F here and get the variable that we store it in, which is Gemini API key, we copy that, paste that in here with an equal sign, and go back into the repository and right-click on Google AI Studio. If we open that, this is where we create the API key. We select Create API Key in the top right corner, give it a name, select Default Gemini Project, and Create Key. Once that's completed, you should be able to copy an API key given to you here. Once you copy it, just paste it in here and save this file. Once that's done, next thing we need to do is spin up our virtual environment. And to do so, we need to open up the terminal in our project and type python 3-m vnv. And as soon as that is done, you need to type source vnv/bin/activate and hit enter. Now you're in your virtual environment, as you can see here. The next thing you need to do is to actually open up the Docker desktop, and it should look something like this. And as soon as it's open, you can head over to the repository again, Command F, docker compose, and find this command over here, docker compose upbuild. Copy that, paste that over here, and hit enter. And while we're waiting, we can go ahead and grab the next command that we're going to have to run for Docker. So as soon as you see Project Insight Consent Agreement, you can actually Control-C out of this. And as soon as that's stopped, we paste the command that we just copied from our repository. And that should spin up our application in Docker and be able to actually interact with it. As you can see here, it is ready for you to interact with. Finally, the last thing we need to do is the way our application accepts zip folders is if we open this zip folder over here, we would see that it gives us one main folder, of course, and in that folder we'd have 3 separate projects, or one project, or as many projects as you want, all split up in their own folder.
Project setup has taken place. The app starts by asking the user for consent through our consent agreement manager. The user is able to see more privacy details by typing more into the terminal, into the command line here. The user must accept the preferences by entering yes. If the user does not accept, the app will exit. So from there, we ask for user configurations, things like their email, GitHub username, industry, and current or aspiring job title. These preferences are stored in the database and used later down the line for analysis. Once consent and user preference has been stored, we request the user uploads their file to localhost in order to get an upload ID. They must upload a zip file of the project in the correct format. For testing purposes, I will upload one in the wrong format. You can see here an error message is presented. So let's upload a zip file in the correct format and just copy and paste this upload ID into the terminal. Once the project has been uploaded, it is scanned and the paths for each project are extracted. At this stage, we use the file paths to hash a unique signature for each project so that we can check if it has been previously analyzed or not. This way, we don't have to store any raw file content from the user into our database. So all we scan and store is the project name, duration, and signature path using the project metadata. Files are then parsed to determine if they are code or non-code before the user is provided with 2 analysis options: local analysis or AI analysis. We see the privacy implications initially listed for AI analysis here. If the user selects AI analysis, they are prompted to accept a secondary consent for third-party data sharing. So we see here that at every possible stage, we inform the user of the implications and request consent as necessary. Now to see what is produced when the user selects local analysis.
We begin by identifying whether a project is individual or collaborative using Git authorship. We analyze contributors across both code and non-code files, giving a much more complete picture of who contributed what. If a project has no Git history, then we classify it as an individual project. For coding project, we detect all programming languages present, even in multi-language repositories, and identify frameworks used during analysis. As we can see here. For non-code documents, we determine whether each file is Word, PDF, or plain text so that it's routed through the appropriate parsing pipeline. Next, we extract contributions for both code and documentation. For Git repositories, we analyze commit history to understand how much each person contributed, total files changed, total lines modified, and how work progressed over time. We also compute activity type metrics like code files changed and test files changed. For non-code projects, we identify the different types of documents worked on, like installation guide, tutorial, etc. This gives a rich multi-dimensional view of contribution and project effort. Our system extracts skills from both code and documentation. Code reveals technical skills, non-code shows soft skills. Once both analysis complete, we merge everything into a unified project profile, summary, skills, contribution metrics, completeness scores, and extracted signals. We then compute a project score used to determine project rank. For Git projects, we use weighted metrics such as commits, code files changed, test files changed, etc. For non-Git projects, we incorporate file counts, maintainability score, complexity score, and class complexity, etc. Finally, we blend the code contribution, documentation contribution, and the documentation completeness score to produce a normalized score from 0 to 1, which is used in our rank. After merging the full analysis and calculating the score, we store everything in our database: skills, summaries, contributions, metrics, Git history, generated resume bullets, and version timestamps. The portfolio dashboard then displays each project ranked by importance and organized chronologically with all extracted insights available in one place.
Three top ranked projects. As previously explained earlier, we assign a score to each project or rank to each project, which is between the values of 0 and 1. So here we show the summary of the top ranked projects and their associated skills. For example, the top ranked project at which we scanned was the Git demo, which has 7 skills, and there's a brief summary as well as key skills associated with that project. We also assign a little badge just to show it's ranked between 1, 2, and 3. Then we have the chronological order of the projects, which are sorted by the most recent, and in this we also have the Git demo project to be the most recent as well. This is currently just capped at the 3 recent because we've only scanned 3 recent projects. And then we see the chronological skills evolution, which happens from when the user first applied that skill to over time. So for example, we can see that analytical thinking was first used in non-code projects, which is linked to the date created for non-code project of October 24th. And then this also highlights the soft skills and technical skills as well. As we can see, we also have some languages shown and backend. Then we have most frequently used skills as well across all projects, which includes backend, front-end, analytical thinking, and it shows you how many projects that you applied those skills so far. Then we just have a resume summary, which shows all the resume bullet points, and for each project it shows resume bullet points associated to those projects. Now I want to go into review previously generated sites. We've already consented previously. We have our user preferences stored. So it says we have previously found generated insights for a project. Would you like to view your resume? Yes. So as we can see now, we can see our previously generated portfolio information. Here's our previously generated portfolio information showing the projects as well as the duration, summary, and skills with metrics. It also shows the top ranked projects, chronological list of projects, the resume bullet points. We'll be showing the delete previously generated insights. To run the previously generated insights, the command on running this would be different. We would use docker compose run rm-it, and then it should end with app.cli.delete insights. So this would show us the previously generated insights that we had in our database. Currently, we can choose the option, the user should enter a number associated with these projects. You see the name of the project and a few characters of the project signature. So I'll be choosing number 2. And then it would ask you if you want to delete this project, and you say yes. And just for an extra confirmation, we also added the name of the code project plus the file signature so that the user can confirm that they are actually deleting this project, and maybe typing in just yes or no was not a mistake. So we would type in code projects
7p87. And then it has deleted the insights for code projects.